So, it's bloody, it's beating, it's fat, and it's very vital to your body. The heart is actually the biggest organ in your whole entire body. And it also is very kind of just maybe worth living for. Pun. So with this is a 3D heart. And actually at the College and Career Center they will teach you, if you ever take that class, to do this 3D print. Today I'm going to be showing you how to do a sagittal view and how to label the heart. So I'll pass this around later. A sagittal view is when you cut the heart sideways. So by sideways, I mean this way. There's two other ways to cut a heart, from the top and down the middle. Here at the top, if you saw the top, you'd see the two parts of the ventricles and the atriums. The ventricles are located down in the bottoms here, and the atriums are on the top. The reason why they're so different is that the ventricles hold the blood, where the atriums push out the blood. Now they come out of arteries, and there's two main arteries that you should know. The superior, and then the inferior vena cava. Then up here is the aorta. With the aorta, they have a weird tendency to have a large vein or artery to pump through the whole entire body. The smaller ones go to the lungs. The reason why they're small is because your lungs are more closer to your heart than your whole entire body would be. Hence the reason why the vena cava is larger. The smaller parts of the aorta is called the pulmonary semilunar valves. And then the bigger part is the pulmonary valve. The reason why they're so different is that the semilunars look kind of like the semi part of a moon when you look at it. The pulmonary valve is just there to be a large moon, basically. So, what makes the heart beat? Well, people say that there's no such thing as electricity in your body. Well, they don't know, scientists. So, this is called the SA and then the AV. And that is short for semi-atrial, which is in the atrium, and the atrio ventricle, which is in the ventricle. These two like to talk together to keep your body pumping, and electricity is what makes it go in and out, in and out. So without that, how will we know what to do when there's like blood flowing over the ventricle or the atrium? What comes into play is the tricuspid and bicuspid. The tricuspid is located on the right side, and the bicuspid is located on the left. The reason why this is the left and this is the right is because when you look at the heart, you're going to look at it in a different point of view. So when it's in your body, it's still your right and your left. When you cut it in half in the sagittal view, you're going to flip it over to where these are different sides. So with that, a tricuspid has different, like literally 3 different webbings. The reason why there are 3 different webbings is that we use mostly our right side of the heart to pump out the blood to our whole entire body. Like I said, bigger arteries, bigger webbings. This one's smaller because this side actually goes to the lungs. Without these webbings, you can actually die from heart attack. Well, not heart attack, heartbreak. Of course you can die from heart attack. But the reason why people have heartbreak is because they actually have cardiomyopathy. Cardiomyopathy is when you have an enlarged pulmonary valve and enlarged superior and inferior vena cava. So when these are enlarged and you're under stress, what would happen to your heart? Your heart overbeats or underbeats, to where these little webbings start to break and tear. So without them, your whole heart will overflow with lots of blood. Actually, you produce about 12 gallons in your body. Another disease